Hello. So in this example, we are tackling higher derivatives. In particular, we have our problem here. So suppose we have a function that tells us sort of the position of a particle at some time t in minutes, which is important, right? Keeping track of units. And it wants to know the acceleration of that thing after 90 seconds. So remember, right, by sort of convention, we have names for these functions, right? So s of t conventionally is position, but it told us that that's what position, right? That this is a position function. So whether it's called s or f or p or whatever, it doesn't really matter. But what's important here is that we know, right, the relationship between position, something like s of t, and then velocity. So in particular, so we might do something like v of t, which is really sort of the first derivative of position, right? So v of t is really s prime of t. And then acceleration, a of t, is the first derivative of velocity, which is also then the second derivative of position, right? So in particular, this thing wants to know the acceleration, and we have position. So really we want to use this bottom part here, and we want to use, right, the fact that the second derivative of position is acceleration. So the first thing that we need to do then is take our function and take the second derivative, right? So we'll have to take the first derivative and then another derivative, okay? So start with my s of t function. So s of t, so that thing is 4.9 t squared, t cubed. Let me write that a little cleaner. So 4.9 t cubed minus 13 t squared plus 12t and minus 1, okay? So then I'm going to take the first derivative. So I'm going to take s prime of t, which to be clear then is v of t. This is the velocity, right? But I'm just going to be doing that sort of the standard way. So I'm going to take down the power and multiply and then subtract 1 from the power. So I have 4.9 times 3t to the 3 minus 1 minus 13 times 2t to the 2 minus 1 plus 12 times 1 times t to the 1 minus 1, and the derivative of constant is 0, right? So if I clean this up then, this is going to be 15 minus 0.3, so that's going to be 14.7 t squared minus 26t, right? Because that's 2 minus 1 plus 12. But again, this is the velocity, and what I want is the acceleration. So I'm going to go one more. So I'm going to do, sorry, it's a little dry. So s double prime of t, which again, to be clear, this is the actual a of t. Does that show up okay? Yeah, I'll switch over. So let me rewrite this, because I don't know if that actually was terribly well visible for you guys. So let me do it this way. So I want s double prime of t, which again, to be clear, is a of t. And the same deal, right? It's still a polynomial, so I'm going to take down the powers. This is 14.7 times 2t to the 2 minus 1 minus 26 times 1t to the 1 minus 1, and then the 12, the derivative of that, since it's constant, is just 0. So then cleaning this up, I'm going to get 29.4 t minus 26. Okay. So I've got my acceleration. So it seems like it would be pretty straightforward, right? It wants the acceleration at 90, so I just plug in 90, right? No. So hopefully you were yelling at your screen going, no, don't make the mistake, right? Classic easy mistake to make. Remember, we want to look at the units, right? T here, right? T is in minutes, and the time it gave me was in seconds. So I have to convert that, right? So in particular, 90 seconds is really 1.5 minutes, right? So I need to make a note, right, that T is 90 seconds. So I'm going to write this out, even though it's sort of hopefully not going to take that much brain power to do this. 90 seconds in minutes. But that means that T is really 1.5, right? And you can get this by taking the 90 seconds. Again, this is not probably a problem you would need to do this method on, but for other ones, maybe that has like more difficult conversion, this might be a sort of a method you could use. So this is called dimensional analysis, if you've seen this before. But the idea is that you take what you have, and then you sort of treat the unit itself almost like part of the fractions. The idea is you want to get rid of seconds, and you want to have minutes, right? Because you want it to be in you want the unit to be in minutes. And so if you have some amount of seconds, you would cancel the seconds. And the idea here is to make this 1, meaning that you want to write the conversion. 1 minute is 60 seconds, right? And so the idea then is like these seconds sort of cancel out, and so you end up with 90 minutes over 60, right? So you would sort of multiply straight across, you get 90, and now I'm in units of minutes over 60. And then if you sort of reduce this, right, you get 9 over 6 by dividing both by 10, which is really 3 over 2, which is really 1.5. Right, so this is a way you can sort of do a unit conversion, which again, in this case, it wasn't that hard. You probably could think like 90 seconds is a minute and a half, more or less off the top of your head. But if you were given yards and you needed to convert it to, I don't know, inches, or you needed to convert like miles to inches or something, like you might need to have some extra steps involved, especially if it were like miles per minute to feet per hour or something. You have to do all kinds of weird things to keep track. This is a good way of doing that, okay? Regardless, once I've sort of figured out where I need, or I should say what value I need, so now I have t, so I can plug t into my actual value. So what I want to evaluate is a of 1.5, which is 29.4 times 1.5 minus 26. Clearly somebody is evil, giving me all these annoying decimals. So 29.4, so that's going to be that plus half of that, so that's going to be what, 14.7. In fact, that's where I got that from. So this plus 14.7 is going to be what, 44.1, I guess, if I did that right. Hopefully I did. Minus 26, which is then going to be what, 18.1, I think. Again, feel free to check my numbers here. So 18.1, although I guess strictly speaking, I shouldn't just circle that, because again, I should give units. And in particular, right, I know my time, t, and it gives me position, but I forgot to give units for. So let's say this is feet, because I made the question, I will do that. But if you're not sure, you should always ask whoever gave it to you. So if we assume that the position was given in feet, this would be something like feet per minute, right? Okay. All right, so again, position, right? Derivative position is velocity, and then derivative of velocity is acceleration. That's how I got my acceleration. So I took my position formula, took 2 derivatives to get my acceleration formula, and then plugged in the t I needed, which I need to do a little bit of conversion, right? So this is 1.5 minutes. Plug in 1.5, compute, and that's my answer, okay? So that's that. Hello. So In this example, we are posed with what seems to be an easy question. And in fact, I'm going to sort of do the question deliberately incorrect to show sort of how you can catch the fact that it seems odd, and then how to sort of backtrack what we need to do, okay? So I'm going to sort of do a quick version of this problem first, but to be very clear, there's going to be a mistake made, and I encourage you to sort of figure out or see if you can find out what the mistake is. And again, to be clear, the mistake isn't computational. I hope not, anyway. If there's a computational mistake, that was not intentional, but it's going to be a logical mistake, meaning that I'm going to make an assumption that seems like it should be easy enough, but it turns out to not be true, okay? So stay on your toes, see if you can see what I'm doing. All right, so we have a car moving along some straight road, right? And we're given some position of that car, some s of t. And so the idea here, right, so t is given in seconds, but the idea here is it wants to know how far the car has traveled, so the total distance that the car has traversed sort of over the period of the first 6 seconds, okay? So commencing the sort of incorrect approach, I could say, okay, well, my car is wherever, right? I could assume that it starts at 0, but let's not assume that. And in fact, really what it seems to be the case is that it's right over the first 6 seconds. So really I'm talking about the interval, let's say 0 to 6, right? So it seems like then I should be looking at sort of where I ended, s of 6, minus where I started, s of 0, right? And so to be clear, I'm looking at where I ended versus where I started. Okay. So this isn't so bad. So all I need to do is plug in the 6 and the 0, okay? So again, to sort of remind myself, s of t is -2 t cubed plus 12t squared minus 32. So I want to plug in 6. So s of 6 is -2 times 6 cubed plus 12 times 6 squared minus 32. And s of 0 is -2 times 0 cubed plus 12 times 0 squared minus 32. So in particular, s of 0 then is 0, 0, -32. So I guess it's good that I didn't assume I started at 0, because really I started at -32 for some reason. But when I plug in 6, what do I get? Well, 6 cubed, so that's 6 times 6 is 36, times 6 again. So that's going to be -2 times 216 plus 12 times 36 minus 32, which is going to be -432 plus, so that's going to be 360 plus 72, so that's going to be 432 minus 32. But these cancel, so that's -32. So that tells me that s of 6 minus f of 0 is really -32 minus -32, which is 0. So doing it this way, I claim that my car has traveled a total of 0 distance. This should be worrisome. Now, there's a key word here that should make this worrisome, which is that I want to know the total distance traveled, not the net distance traveled, right? Because it's certainly plausible that you could be in a car driving in one sort of linear direction, meaning you're either going straight forward or straight backward, and you could end where you started, right? Because you could drive forward for a little while and then reverse and drive back for a little while, or vice versa, right? And you could end where you started, in which case your net distance traveled could certainly be 0. But total distance traveled should actually add up all of that distance. So if you go 20 feet forward and then 20 feet back, your net distance travel will be 0, but your total distance travel will be those 20 feet and the reverse 20 feet for a total distance of 40 feet, okay? So if my claim then is that my total distance traveled is 0, the only way that can happen is if my car was absolutely still the whole time. But if it's still the whole time, well, that means that the position never changed. The position was 0 all the time. And that function does not look like it tells me it's 0 at all the different times, right? Or negative 32, as it were. So there's something dodgy going on here, right? And as you may have guessed, based on my description, what's happening is that essentially somewhere along the line, this function is telling me that my car is changing direction, right? It's going one way for a little while, and then it sort of stops and comes back. Or, it's either going backward for a while and then goes forward, or it goes forward for a while and then goes back. But either way, it's stopping at 6 seconds where it started, but it did move in the interim, okay? So how do we figure out the total distance traveled, right? So right away, I sort of looked at this and went, that doesn't seem right. 0 does not seem to be a plausible answer, right? So, it's not technically impossible, but sort of extrapolating from that, the only way it's possible is if this function is 0, or a constant value, negative 32, from 0 to 6, and that's clearly not the case. So this tells me something went wrong, which brings me back to thinking about it for a little bit, and I'm like, okay, it must have changed directions. Now the question is, how do I tell where it changed directions? Well, what's different about changing directions, right? If I'm going forward for a while versus going backward for a while, what's the difference? Well, my velocity has to change, right? My acceleration may not change. So for example, think of like throwing a ball in the air. That acceleration is constant. It's being sort of constantly affected by gravity, more or less. We're not going to get into like wind resistance and the minuscule change in gravity between heights or whatever, but like let's call it constant. And you could throw it up and it's going to have some initial velocity that goes up for a while, and then eventually the acceleration overcomes it, and then it goes down for a while, and then you could catch it in the same spot. And that's essentially what's happening here, right? So I can't necessarily use the acceleration because that could be constant, but the velocity changes, right? So with the ball example, throwing it up, it goes up for a little while until it hits sort of its peak, and then it goes back down. So it has positive velocity for a while, then it hits its peak, and then it has negative velocity for a while. And when it hits its peak, what's the velocity there? Well, it's not increasing because it would be still going up, and it's not decreasing because it hasn't started falling. So if it's not positive and it's not negative, it's got to be 0, right? Okay, so this is the chain of logic to think through for the problem. So what this tells me then, so I need to know specifically, I want to add up the amount of distance it sort of goes forward and then the amount of distance it goes backward, and add those together sort of as a magnitude, right? Instead of trying to look at the sort of net displacement, I want to sort of add up all the forward change and all the backward change as separate things, which means I need to know when is the car going forward and when is it going backward. And in particular, like we said with the ball example, right, same sort of analogy, I need to be able to spell. So I need to know at what, wow. I'm getting ahead of myself, and I wanted to write time, and so the E just sort of plopped itself in there. At what time, because it's possible my car, unlike the ball, sort of goes forward, backward, forward, backward, forward, backward, forward, backward, forward, and then back to where it stopped, right? So to some extent, it's possible the car keeps going back and forth. So I need to know what time or times the car changes direction. Okay, so this is my goal then. So to figure that out, I need my velocity. I know that for sure. So I'm going to take my s of t function here, and I'm going to find velocity, which, if we recall, velocity, v of t, is s prime of t. So that's going to be -2 times 3t to the 3 minus 1 plus 12 times 2t to the 2 minus 1. And then minus 32 is just 0, right, because the derivative of constant is 0. So I'm going to get minus 6t squared plus 24t. Okay. And I want to know, when does it change direction? So really what that's asking me is not just sort of when does the car stop, because I could drive forward in a car, stop, and then keep going forward, and that would be fine, right? So it's the change direction. I want to know when it goes from forward to backward or backward to forward, which means really I want to know about the sign of my velocity, right? I want to know, does it go from positive velocity to negative, so that'd be going forward to going backward, or when it goes from negative to positive, when it goes from going backward to going forward, right? So to do that, my first step is going to be to sort of just factor this thing. So I'm going to pull out a -6t. So that gets me a t left over here and a -4 there. So particularly this thing is 0 at 0 and 4. And the only one of those that I need to worry about, right, like technically they're both in my interval, but one's an endpoint, which tells me that it sort of starts going at 0, which makes sense, right, because that's when we're sort of starting the clock. So that 0 isn't a big deal, but I want to know about 4, right? So to do this, I'm going to do my sign chart. So sign chart. So remember, sign charts, super useful in calculus. So I'm going to draw up my little number line. I'm going to put the zeros of my functions. I have 1 at 0, 1 at 4, and then I'm going to test my signs here. So really the only ones I care about are these two, but I'll do all of them just because why not? So if I pick some giant negative value, like -1 billion, right, then this is going to definitely be negative. That t is negative, and I have a negative out front. So I'm going to get a negative, a negative, a negative. I'm going to get 3 negatives. So that's negative there. If I pick some positive value, some giant number like 1 billion, then the -4 does nothing, so I'm going to have a positive in there. The t itself is positive, but I still have the negative out front, that -6. So I have 1 negative, so that's going to be negative. And finally, this is probably not surprising, but if I plug in some value between 0 and 4, so let's say 2, then 2 is positive, 2 minus 4 is negative, and I still have the -6, so that's 2 negatives. 2 wrongs make a right, at least in math. All right. So what this tells me is that at 0, I went from going sort of backward to forward, but I don't care about that because that's my end point. But at 4, I go from forward to backward. That's the key, right? So my car sort of went forward for the first 4 seconds, but then stopped and reversed for the last 2 to end up where it started. And that's where I got this crazy 0, right? So what that tells me then is I want to know the total distance traveled from on the interval 0 to 4, because that's when it's all going the same direction. And then I want to know the total distance traveled from 4 to 6, because that's all the same direction. And then I want to add those magnitudes together. I want to take the absolute value of those things and add them together, okay? So this tells me I want s of 4 minus s of 0 and s of 6 minus s of 4, right? Because really, this is telling me like where I ended up versus where I began when for that whole time that I'm going forward. And really, I could sort of cheat because I know that this value is going to end up being the other one because I know I got 0. So I had to end where I started, meaning that however far forward I went, I have to go back that same amount. But let's pretend I don't know that so you can sort of see the full process. But the good news is I know what s of 6 is and I know what s of 0 is. They were both negative 32. So really all I need to do then is solve for s of 4 still. So if I plug that in here, right, and remember it's s, not v, so I'm doing it in this my original function. So I have minus 2 times 4 cubed plus 12 times 4 squared minus 32. So 4 cubed is 16 times 4 is 64, so minus 2 times 64 plus 12 times 16 minus 32, which is, let's see, negative 128 plus, so then that's going to be 160 plus 32, so that's going to be 192 minus 32. So my positives is just 192, my negatives is 160, so I'm going to get 32 as my result. So that tells me then that s of 4 is 32 minus 32, and s of 6 was minus 32 minus 32. So this is going to be 64. And this is going to be, unsurprisingly, negative 64, right? Because this tells me that I went forward 64 feet, and then in the last 2 seconds, I went backward 64 feet, which is how I ended in the same place I started. But remember, when I want total distance traveled, I want to add up the absolute value of these things. I want to add up all the distance as some sort of magnitude. I don't care about the direction, right? So really, my total distance traveled is going to be the absolute value of each of these things added together. So it's 64 plus absolute value of negative 64, which is 64 plus 64, which is 128. Okay. So the takeaway here is when you're trying to figure out total distance traveled, which to be clear, again, this is 128 feet. So when you're trying to get total distance traveled, that's a key term, right? So total distance traveled is not net distance traveled. So I can't just do this sort of nice idea, which is not quite what I'm after, right? So in order to get total distance traveled, I sort of have to check to see, did the thing change a direction? And if it did, then I have to sort of break up my computation, my net distance traveled computation, into each segment, right? So that I look across all the segments that match what I'm after, 0 to 6. So 0 to 4 is one segment I did because that's where it was all the same direction, right? They were all positive velocities there. And then 4 and on was all the same. It's all backward, but I only wanted up to 6. That's why I did 4 to 6, because that was a segment that all the velocity was the same sign. And once I get each of those pieces, however many there are, I add up the absolute value of each of those sort of segments, because I, again, don't care about the direction, I just care about the amount of distance covered, and that will give me my answer. Okay? So that is that.